birds or animals in general. And we tend to think that the major issue is roadkills, because then clearly we can see the outcome, the negative impact of the road. The animal is lying there dead. So that's quite trivial and visual, and we can see this problem in our own eyes. But this paper is very unique because what they did, Jesse Barber and his students in the United States, what they did was to study the impact of a road without an actual road. Instead of studying the impact of an existing road, what they did was to travel outside of the city to a mountain ridge in Idaho, United States, where there are no roads. And they placed an array of speakers, only broadcasting the noise of cars passing through the forest, without cars passing through the forest. And their results were striking. They found a reduction of about 30% in the number of birds in this area, migratory birds. During autumn migration, the birds pass in the area, and when the speakers were on, there were 30% less birds than compared to when the speakers were off. And I was really impressed by this number. This is not something we can just ignore, in my opinion. This is a huge impact. And in follow-up papers, they were also able to show that it was mainly the juvenile birds that were affected by this noise, meaning that it has also consequences on the population, and the ability of populations of birds to really persist over years depends a lot on their ability of recruiting young birds and keeping those happily alive and migrating through habitats without needing to avoid them because of noise. And they also showed that the feeding rate of individuals was degraded when noise was on. So birds were less feeding and spending less time feeding when noise was on compared to when noise was off. And this, I don't know, several very interesting papers or experiments showed me that we kind of ignore something very essential to the way birds sense their environment. I thought I knew quite a lot after 12 years of working with lots of researchers around the world, but we kind of missed the fact that birds really rely a lot on their hearing when sensing the environment. Now, originally I come from the city of Jerusalem, which is a very loud environment, but nowadays I'm happily living in the middle of the Israeli desert, the Negev desert. This is the view 3 minutes from my apartment, and these are wild ibex, an endangered species, watching the cliff. This is the best location to take your cup of cold coffee in the morning. It's the desert again, so it's quite warm in here, and sit and think about what you should do with your research and how to continue analyzing your data and fight with R and statistics. So this is like the best spot to sit. And this spot is not so much exposed to noise pollution. In fact, there is only a minor road down this cliff that leads to a nearby nature reserve. But what I want to emphasize here is that I'm enjoying a very unique situation on a global scale, because many of the countries nowadays look like this. This is a map of the main roads in the United States of America, where you can see the maybe most obvious meaning of roads is that they connect human settlements and activity centers one to the other. So to do that, they have to penetrate the open habitats and the conserved areas and nature. And in fact, they calculated in this paper that is cited down here that 80% of the land in the United States, a large country, is within 1 kilometer from a road. It has lots of meanings. It means that animals meet humans probably way more often than we think, but it means a lot about also the water runoff or the chemical pollution that comes with roads. but 1 kilometer from a road, the noise is very clearly audible. Not only in our own ears, but also animals can hear it very well at this distance. And so that means that animals across many countries, not only the United States, this is just the most studied country in the world for that, are experiences loud level of noise. And a paper that came out in 2017 was actually trying to quantify that. This is another, I think, very important paper to understand the meaning of noise and how prevalent it is. So in this paper, they took the nature reserves and the natural parks in the United States, which is all what you can see here from blue to green to yellow. The gray areas are not conserved areas. And what we see here, I don't want to go too much into decibels today because decibels are not very easy for us to understand. Not also for people who are working with this measurement daily. So I'll just say that adding 10 decibels is perceived as doubling background noise levels. And so about 63% of the protected habitats of the natural areas in the United States are experiencing doubled background noise level because of human noise. Mainly transportation, mainly road noise and traffic noise, also airplanes. They were not able to say what's only because of roads, but it's more than half of the area. And if we look at 20% of the area, which is all what we see here in light green and yellow, these are areas where the background noise level is 10-fold higher than the natural levels are expected to be. And that's all because of our behavior or our acts that induce noise into these officially protected, but well, we can see on this map that the meaning of protection is not quite clear, because if we protect a land but it's full of noise, it's no longer very clear what is it protected from. Definitely not from noise pollution. And just to show you here this figure, this shows us the hearing of birds in relation to humans. So I'll focus on the graph first. I'm sorry for all of those that this image makes you a little uncomfortable. I'll get to it in a second. But what we can see on this graph is the hearing curve or the hearing threshold of humans and birds. Humans are in dashed line, meaning that on the x-axis, we can see the frequency. Humans hear pretty wide range of frequencies from 20 hertz to 20 kilohertz. And we can see on the y-axis the level of noise, the amplitude of noise that there should be in order for us to hear a sound. So we hear basically everything that is above this dashed line. And birds, most birds are within this dashed line. So we can actually hear better than most bird species. And that means that whatever we can hear is usually something that the birds can hear as well, especially if it's loud. So these maps that I was just able to show you actually represent also pretty well how birds should be able to hear or not to hear these sounds. But there is an important factor, and that's the way we can actually conceive or accept the meaning of sound, because there's also a conceptual part to sound. For example, on this image here, something that doesn't really occur very often, but I get really bad feelings when I look at this picture of fingernails on a board. And some of us are really irritated by this sound and can suffer for hours afterwards, while others will accept it with no real special attention. So there is also this conceptual component of sound where our understanding is quite limited. We don't really know how animals perceive these added sounds, not necessarily. We can assume that these sounds have some negative impacts on wildlife, but we really actually have to check that before we just run ahead and assume which noises are more or less problematic for wildlife. Now, I'm not a physiologist. There is a long list of papers dealing with the physiology of noise pollution impact. And so we know that birds are, or wildlife in general, not only birds. I know that I've been talking quite a lot about birds, but I've shown you also the ibex, the ungulate. We know that animals do respond to noise pollution also physically, and they have higher stress levels, lighter sleep, lesser abilities to reproduce under noisy environments. But what I mostly focus on is the behavioral aspects. And so I can tell you that we have quite a lot of knowledge on that as well. Maybe the most studied system is birds and bird songs, because birds are called songbirds for a good reason. They communicate vocally on a very large scale, I would say. It's a very important aspect of their behavior. And we know that when birds are exposed to noise, which is what we can see here on the left, they when they're exposed to noise, they also respond to that. Birds can change their vocal communication properties in response to noise. They can, for example, elevate their pitch. They can use higher frequencies. They can use higher amplitude. They can sing louder in case they are experiencing noise. They can change the timing of their song. For example, they can sing earlier in the morning to avoid the masking by noise of traffic that is usually picking up early in the morning when we are on our way to work. And so birds have shifted their frequencies, their amplitude, their time of singing, and we know quite a lot about that. But we don't know much about other components of their communication. For example, their contact calls during flight, during behavior of stopover, when they stop during migration and need to feed rapidly and gain fat to continue flying all the way from Europe to Africa, or from North America to South America, or within parts of Asia. So we know that birds do rely a lot on vocal communication, but most of the studies are actually focusing their breeding behavior and singing, which is definitely very relevant and important for the conservation of these birds, but it's not the only thing. And there's quite a long list of other behaviors that are actually impacted by noise. We know, for example, here, this spotted towhee, these birds are really responding to noise by flying away. They avoid noisy areas, they fly out of them. We know that ungulates shift their feeding and vigilance timing quite a lot, meaning that instead of hearing and listening if there's a predator approaching, when they are exposed to high levels of traffic noise, they spend more time looking around, looking for the predators or the potential threats, and then they feed less, and that might have an impact also on their physical condition. Clearly, animals that rely on their hearing for finding their food, for finding prey, like owls, like bats, they're quite largely impacted by noise, and they usually avoid noisy areas because they cannot feed at the same rate or the same efficiency level within a close distance to a noisy infrastructure. And also parental care was shown to be affected in mammals, in birds, in many other species. So what I'm trying to say here, that all this list of behaviors, although traffic noise or noise pollution does not necessarily alter the habitat or change the habitat physically, and if we look at it, it may look to us as a perfect habitat for wildlife, but it is translated into functional habitat loss, that animals can no longer use these sites as they used to or as they would have without the noise. And so all of this together brings me to my main research questions in my PhD, and not only. And that's what is the impact range in size, in area of road traffic noise on various animal behaviors. And to address that, I've conducted a pretty massive literature review, which I'll explain in a bit. And then also in how much area animal behaviors are affected by road traffic noise. And to address that, we've conducted a mapping project focusing on non-urban environments, the protected habitat, and I'll also mention a little bit the importance of different habitat types, because here in Israel we have quite a lot of habitat types, and we were interested to see if some habitat types are more prone to noise pollution or not. The literature review, we went back to the paper by Sordello et al., published only 2 years ago. This is a very comprehensive literature review. They actually covered almost 2,000 papers dealing with noise pollution in general. And then luckily, during the COVID pandemic, McClure had the time to go over this list of 2,000 papers and narrow it down to only the papers dealing with traffic noise, ending up having almost 200 papers, which is somewhat more manageable in my perspective. And on top of that, I was searching for all the papers that were dealing with traffic noise impact range, how far from a road the impact actually lasts. And we can measure it by distance. In some papers, they mention how far from the road in meters the noise had impact on wildlife. And some of them mention it in volume, in decibels, which is something we can convert to distance surprisingly quite easily. So after all this searching of suitable papers within the list published by McClure and looking at papers that were cited by those papers, I ended up having 30 papers, only 30 papers in the whole world dealing with traffic noise impact range, how much of the area is actually affected by that, or in how much area animal behavior is affected by traffic noise. And I published that in Hebrew. And I apologize for all of you who are interested, but there was a good reason for that. Because nowadays we can definitely also publish in English. My English is not perfect, but this is something that you can manage. The reason was that we wanted to address this issue in Hebrew because we wanted the decision makers and the governmental workers in Israel to actually read this paper and take into consideration noise pollution in Israel when planning new infrastructures, not only roads. And you will see soon the results of the mapping, and you will understand, hopefully, why it had to be in Hebrew, especially if we wanted our government to do something and to do something on that, and I'll go back to it later. So I apologize for the Hebrew, but here you will be able to see these results now in English. So the main outcome of the literature review was this. We took different ranges, different distances from the road. You can see here this car, this is where the road goes, and we can see different behaviors are affected by this traffic noise to different distances. And this is only like a short example. There is the full list of distances going up to 5 kilometers in the Hebrew paper. Again, sorry for that. So we saw that within the first 200 meters from the road, we see lots of different behaviors and lots of different impacts of roads. We tend to think of, as I said at the beginning, we tend to think of roadkill as a major impact. We tend to think of chemical pollution, but actually most papers mention that these effects last only about 200 meters from a road. And this is also where we see most of the impact of the noise on vocal communication of anurans, of birds. We see reduced efficiency of hunting by owls, and some papers mention also bats. So this all occurs within the first 200 meters. But then when we travel further away from the road into the open habitats or the conserved natural areas, we see that we stay with mainly noise impact. Most of the other impacts are closer to the roads. And we see that ungulates, several species, shift more towards visual vigilance and reduce their feeding rate, also 400 meters from roads. But birds breeding, especially in open habitats, meaning fields and wetlands, they are affected up to 1 kilometer from a road. And if we look at medium traffic, meaning that we have tens of thousands of cars per day, not such a heavy level of traffic. We have quite a lot of such roads in Hungary. We see that the max impact on breeding birds, density, and success lasts even 1.5 kilometers from the road, 1,500 meters. And that is quite alarming. And again, this list goes on. And some animals can hear traffic noise only to 1 kilometer from a road, but many mammals can hear a road up to 5 kilometers. And in dense countries like Israel, like Hungary, there are quite a lot of roads within 5 kilometers wherever you go. So this was kind of worrying. And then we took this information and tried to map it to show how much actual area is supposed to be affected by this noise. In order to do that, we took the OpenStreetMap of Israel, but you can take this OpenStreetMap for every country in the world. We took a GIS layer of all the non-urban areas, meaning that all the map on the left here, sorry, is the road map. We can see here on orange and reddish. And here we can see that everything that is white is marked off. This is urban areas. We were less interested in those because there are many types of noise in these areas, and we wanted to focus on the open habitats, the non-urban environments, meaning that we have mainly agricultural and nature reserves. And so this is the blue map here. And we took also GIS layers of the different habitats we have in Israel and the nature reserves. And in order to be very conservative about where do we have actual noise, we calculated line of sight from each road. So this is a very conservative approach because sometimes you can hear traffic noise also when you're further away from the road and you cannot see it directly. But we wanted to make sure that if there is something blocking the road, like a mountain, we will not calculate it as an impacted range of noise. And after running all that information and the different ranges of impact of noise on behavior, we got these maps. If we look at 200 meters from a road, this is a very, I would say, conservative approach. We already have almost 40%, a third of the country is within this range of impact. And we can assume that, for example, birds' communication or animals' communication is affected by noise within about a third of our country. On top of that, if we look at the 1 kilometer or 1.5 kilometers ranges of impact, meaning birds' behavior and breeding behavior, this is quite worrying because we end up having almost 3/4 of the countries within this range of impact. So that result was published in Hebrew in maybe our best journal for nature conservation and ecology in Israel, and it's a peer-reviewed journal in Hebrew, and gained quite a lot of interest from our governmentals. And we are hoping that these striking results will allow us to act and do some better nature conservation within these ranges. But even more than that, if we look at the same results now in a different way, I'll try to explain this graph. We see here again the impact range in the x-axis, and we can see the affected area in percent on the y-axis. So what we see here basically is this map of 200 meters is translated here into the vocal communication of anorans and birds. And if we look about the 400 meters, then we see here the impact on vigilance and feeding trade-off in ungulates. And if we look up to 1 kilometer, this is this point here with this breeding bird. So this is when we look at the impact range of all affected areas on all habitats in Israel. But we wanted also to look specifically at the protected habitats, our nature reserves, and to see if we're doing any better from the United States, for example, or if we're actually protecting our habitats well from nature conservation, from noise pollution. And the answer is not quite. I'm not very happy with this graph. In my opinion, this means that we're not doing a very great job because we can see here that already in like about a fifth of the area of the protected areas that we have, animals can no longer properly communicate or feed. And if we look at other behaviors such as bird breeding, most of the nature reserves are not very well suitable for that. Again, based on literature reviews, based on other species that we have here, but still, if we take these ranges and we assume that they're probably similar to what we have here, this is quite alarming. And if we look specifically at wetlands, this is even scarier or worse. I mean, nature reserves that have wetlands in them or water sources, they're even way more affected by traffic noise, and then behaviors within those areas are much more affected by this noise pollution. And I remind you that I live in the desert and we have lots of importance, like these nature reserves and water sources with wetlands are super important when the Hungarian birds are coming all the way here to fly to Africa, and they need to feed and refuel and drink water. And definitely also our local birds must rely on these water sources if they want to survive. So these are very important sites, and they are blasted with traffic noise. And we can assume that most of the animals that are coming to drink or to feed or to breed next to water sources are experiences some negative impacts of noise pollution. In order to furtherly go deeper in and provide some better estimates of the impact, we also took habitat type and traffic volume into consideration. We got from the government the traffic volumes in each road, in each major road. And then we went to those 30 papers that we found in the literature review and extracted more or less what was the traffic volume in those papers and what was the impact range in open habitats and in densely vegetated habitats. And so I don't really want to go too much into these numbers, but what I can tell you now is that we were able to produce a much more accurate map on how birds breeding specifically. This was the only behavior when we had enough data or enough papers to actually get those numbers. So we were able to produce this map for bird breeding. And if we consider also the habitat type and the traffic volume in the road, we can still assume that about half of the country, not 3/4, but half of the country is affected by traffic noise, and the birds breeding is affected in those areas, especially in the northern part that is more urbanized and has more roads. And if to look specifically, we have a biosphere reserve in the northern part of Israel, where we are trying to protect birds in the Mount of Carmel. And we can see here in this map that most of the area within this green biosphere reserve is orange, meaning that is exposed to noise to a level that is expected to affect animal behavior. Why am I stressing it up so much? Because noise is very easy to map, but we don't always know how much it is affecting wildlife. We can map and give different numbers and decibels and say, okay, here it's going to be 25 decibels and here it's going to be 45 decibels. But we always need to take into consideration not only just the level of noise, which again, we can calculate and see how much it affects wildlife based on their hearing, but we don't know how much it is actually affecting them, considering also how they perceive this noise. So this map is new because it is actually allowing us to say, okay, here, based on previous knowledge, based on lots of different studies, we can assume that birds actually negatively respond to this noise. And this biosphere reserve that is supposed to be a key breeding site for birds that prefer the Mediterranean maki, this habitat of densely vegetated area, can actually use very small fractions here that remain in this dark green. And if we look at an ecological corridor that we have here in Israel, I'm not sure if there are official corridors in Hungary. I'm really not very familiarized with that, but I know that in some countries, ecological corridors are official areas where you're limited by your ability to construct and put new infrastructure to allow animals to pass from one important site to another. And so we have one such corridor here in central Israel where you can see that movement is quite limited. The width of the country is quite limited. And here we see in this ecological corridor that is blue line here, that actually most of the ecological corridor, if not all, is blasted with traffic noise. And maybe for some animals, it is still serving as a good ecological corridor because they're less sensitive to noise pollution. But if you want birds to breed in those areas, it is probably not suitable for all species, and some are strongly affected. And so nowadays, these models are serving us in the process of trying to minimize the impact of noise by starting and having regulation for noise pollution in open habitats in unurbanized areas in Israel. And we work quite closely with the Israeli government to get this new regulations so we can actually protect those birds, those animals that are within these officially protected yet practically not necessarily protected habitats. And in order to complement these models, we're actually also conducting field experiments. As I said earlier, most of the studies are done in the breeding ranges. For example, Hungary is a good example. There's a lot of research going on there, not necessarily directly on the subject of noise pollution, but on birds breeding and success. And what we're now doing here in Israel in the past few years is doing again or repeating the experiment of the Phantom Road, which is what you can see in this image here. These are speakers set in the middle of a wetland in northern Israel, where we try to see how birds respond to noise pollution, not only during breeding or in the breeding areas, but also during breeding here in Asia, and again, in the connection between European breeding grounds and African wintering grounds. So this is where they should stop and refuel and get some energy. And this is similar in a way to where they have studied this in Idaho in the United States. We do have some differences in the different types of sound that we play back in this experiment, but one of our treatments is exactly the same as they did in the United States, with the exact same file, acoustic file. So these are the same cars that traveled through Idaho that are now traveling through northern Israel. And when we broadcast this, you can see that this is the most visible speaker that we have. This is like the end of the road, or the beginning, depends how you want to look at it, but most of the road is actually invisible. These are only the speakers placed in the middle of the reed bed. And what I want to show you now are the very first results. You're the very first ones in the world actually to see these results, because I told earlier, all the conferences, ecological conferences that are in Israel are mostly in December. So I'm just starting now this season of presenting my results. But I can tell you that this definitely has an effect on those migratory birds. I'm afraid I don't remember very well all the names of those songbirds in Hungarian, and I apologize for that. It's been a while since I was mist netting birds in Hungary, and I should definitely go back and see how it works. But we can see here in this graph that is, again, very basic. We just were able to analyze this data after 2 years of repeating this experiment on a weekly basis during autumn migration. So what we can see here on this graph is that on the x-axis, we see time before noise, during traffic noise playback, and after. These are bird ringing days. And on the y-axis, we can see the daily number of birds, how abundant were birds in the area. And so this is statistically significant that the bird numbers were reduced during noise compared to either before or after noise was broadcasted. And again, these are very first results, but it is very similar to what they were able to show in the United States. We're talking about 10 to 20% decrease in the number of birds that were present in the area during noise playback, traffic noise playback, compared to the control settings. And even more than that, what we were able to do here in Israel, which was not done in previous studies, was to tag some of these birds and focus on their movement behavior, not only avoidance behavior, but also movement behavior. So we have here a very unique system that is called the Atlas, animal tracking system. And here what we can see on this great reed warbler, which I surely should have remembered the name in Hungarian because I've seen quite some of those, but you can see here that there's a tiny tag barely visible on the back of this bird, and there's an antenna here. This is a sticker that goes off before we release the bird. So basically this tag is tiny, it's about 1 gram, and it provides us the location of the bird every 4 seconds during the stopover, during the migratory rest that they do here in Israel, in this wetland in the north. And here, for example, on this map, we can see the movement of several individuals. Each individual has its own color, and we can combine the movement data with the noise levels that it was experiencing and we were measuring in this area. Unfortunately, I didn't have yet the chance to analyze this data, so I'm not going to provide you with any exciting answers about that, but it's already exciting enough that we can track animals, these tiny little birds, in such an amazing resolution. And so I've been lucky enough to be one of the very first students to actually work with this system, and I really do hope that in some years I'll be able to provide you with some better answers on how noise affects not only habitat selection during migration, but also movement and movement patterns, habitat use, so we can learn better what are the impacts of noise, which types of noise affect animals more than others, and to do some better work for conserving those animals that are doing amazing flights, again, all the way from Hungary to us. During this project in the past 2 years, I was lucky enough to get 2 birds with Hungarian rings on their legs and 1 Romanian. So we don't get a lot of birds here in Israel with rings from other countries. Most of our birds come further east from Russia, for example, where they do a lot less bird ringing. Luckily, Hungarians are very much into bird ringing and provide us with a lot of better understanding on our environment, because we can know better where are these birds coming from. And this also actually works a lot, not only good for science, but also good for advocacy and conservation, because when people are aware of the fact that these birds, these tiny little gray or brown thingies that we catch here, are coming all the way with their 20 grams from Hungary, this gives a bit more understanding of the importance of this small wetland here in Israel, that other than that it has also our local birds, is actually having lots of guests, tens of thousands of guests every autumn and every spring on their way to or from Europe. So to summarize it all together, noise pollution is prevalent. It's everywhere. We've seen the maps. It's very hard to avoid it nowadays, but it's not trivial. Although we can map noise pretty well, we're not very good at understanding this invisible pollutant. We're very visual creatures as humans. We rely a lot more on hearing than what we think we are, but it's sometimes hard to conceptually understand that. Yet it has a broad impact. We saw lots of different behaviors, and of course, we've neglected the physical impacts, but it has also physical impacts. And so we should definitely quantify those impacts, and we can do that relatively easily. Looking at behaviors is relatively easy. We still quite have a lot of missing data. We've went back into the literature and found a lot less information than we thought we would. We still don't know very well which species are more vulnerable to noise pollution, what behaviors are exactly affected by noise. We have quite a decent list, but which ones are more important than the others, and how often does it happen, we don't really know. And of course, as I mentioned, the range of impact, how far from the road, on what levels of noise, which frequencies are more important than the others, which also translate into a range of hearing. This should all be available better and mapped so we can do better nature conservation. So that's what I'm trying to do here in one project, but I have lots and lots of collaborators here in Israel and around the globe to support this effort. I'm the only one to present this presentation today, but I'm definitely not the only one behind this project. And so I would like to thank very much my funders, all my peers and supporters, and I'll be very happy to take questions if you have any.
Thanks so much. That was great. Thank you. Great overview. So now we have plenty of time for questions.
Thank you so
from
much.
the audience. Phaedra.
Hello.
I was wondering if you're also advocating for in the future for the corridors you mentioned. So to also protect the noise pollution at those corridors, or is there other solutions you propose?
Yeah, so there are two main things here. Thank you for this question. This is a very important one. There are two main things here. One is that we simply have to take into account noise pollution when we're planning conservation efforts, and that's not so much done nowadays. Not in Israel, not in other countries. Most countries completely neglect the importance of noise pollution, and they do not map it, although it's doable. They do not address it, although it's doable. And so when planning a new road, for example, people are calculating the amount of area that will be affected by the road, but they plan it without the noise itself. They just plan how much area will be cut by this asphalt. And sometimes they do also appreciate the fact that it will be like a blocking factor for some species and will affect movement, will affect the movement of water. But noise is not part of the calculation that people do when planning. So one of the things I'm advocating for is simply put it into these models, simply account for that also when planning and when considering where to place noise infrastructures, because with roads, it's very hard to just avoid them because of the impact of traffic noise or this. But if you have to decide where exactly to plan the road or how exactly will it look like, then we can do better when we also calculate noise pollution. And there are many other infrastructures. I was talking today mainly about noise from roads, but I've been studying also wind turbine noise and water pumps and gas pumps. And so all infrastructures, most infrastructures that we are actually planning produce some level of noise, even electric wires. So just by calculating also the ecological impacts of noise on wildlife, we can do better and more reliable planning. And on the other side, we can also reduce actual active or present noise that we have in sites that we think it's needed. Humanity had accepted the fact that noise has impacts. And so there is a very long list of papers dealing with noise pollution impacts on humans. Sleep ability, stress, studying abilities, focus. So we know quite a lot about this impact of noise, and we have quite a lot of regulations for noise impacts on humans. And in order to handle that, we have developed quite a lot of tools to reduce noise propagation towards houses. So my main point here is that we have tools that we can use to do better conservation. For example, in ecological corridors, that we acknowledge how important they are, or in wetlands, because we understand that they are super important habitats, especially here in Israel, but globally speaking, we know that the wetlands are at risk. So we can definitely use that. We can use different asphalt, we can use different blockers, we can use different vegetation. Like if we put dense vegetation next to roads, we know that it blocks traffic and noise to some degree, but we have to use it wisely. I mean, in the middle of the desert, I'm not going to suggest that we will put lots of vegetation next to the road, because that's going to create actual ecological traps. It will create lots of species coming to enjoy this greenery and then getting passed by cars. So we have to be also very careful as ecologists and think of all the different effects that our suggestions have. I'm just saying that noise pollution is addressable.
Thank you for your answer. Thanks for the great presentation.
Thank you so much.
Thank you. I think Shamim is next.
Okay, thank you very much. That was a great presentation. I have around 3 questions for you. The first one is...
Oh, hearing now very bad. I'm sorry, can you say again?
Okay, is that better?
Yes.
Good. I was saying thank you for the great presentation. So I have around 3 questions. One of them is, you mentioned that noise can generate stress, and I believe that can jeopardize the wildlife reproduction. I'm just wondering whether there is a direct relationship between noise pollution and the extinction of this species. And then another one is, from your research, what is the permissible level in terms of decibel?
Wow, I'm sorry, I heard about the extinction, but then I lost you pretty much. I heard very little of it. Sorry.
I'm sorry.
Shamim, what you can do is you can type your question into the chat window, if that, or get closer to the microphone.
I think that's okay. My network keeps dropping. I think I can just chat. If that's fine.
Yeah.
Okay.
So regarding the extinction, I hope I heard it well. So the paper by Buxton et al. From the United States, published in 2017, was actually trying to look into that. And they were able to show that a very important portion, I think it was 14% of the important habitats that also have vulnerable or almost extincting species were exposed to very high levels of added anthropogenic noise. So we don't have here in Israel any example that can prove that birds got extinct because of noise. However, we do know that if we look at the habitat scale, maybe species were not disappearing globally, but in some areas they definitely do leave entirely very large patches of habitat and avoid them completely because of noise. So they're locally extinct or functionally extinct from those sites. So at the site level, definitely we know that animals disappear completely. And we can see that also in urban areas. Not all species can penetrate the urban areas and thrive there. And one of the reasons that we know of is because of this noise. So I hope this answers this question. I hope I got it right.
Yeah, I got that right. Thank you.
I think our next question came from the chat window from Reiko. Hi, thank you for the presentation. You had a graph about individual numbers on Phantom Road on noise treatment. Do you have any idea why it could be that the individual numbers are higher after noise treatment than before it. Was that a significant difference? I guess that's your experiment, right?
I guess so.
Mhm.
So I'll just go back to this figure so you can see it again. So yeah, what we can see here is that these asterisks are between the before and noise treatment and after. There was no significant difference between the before and after. And this could be just because of stochastic changes and differences in numbers of birds, because we are working at a migratory site. So what we did here is that every treatment was only 2 days long. The before, the during noise, and after. Every phase was 2 days, so we could have a whole repeat of the experiment every week within 6 days. And then we left the site for 8 days and returned back only like after almost 2 weeks to make sure that the birds have been actually changing. So every site was used only every 2 weeks for 6 days. So all the birds could switch during this migration, and there's a lot of difference between different days. So I was actually surprised to see this pattern. I wasn't expecting that, because we have very strong, we call it waves of migration, that birds arrive at a big number because of good weather, and then they land, they use the area. Some of them stay only for 24 hours or even less than that. They land early in the morning, they spend the day at this site, and then they leave in the evening. But the reason we did that at the Hula Nature Reserve, which is a quite decent wetland for Israel, at least for our desertish area, is because also some birds actually stay there for several days to collect fat, to gain fat, to gain weight. And so they feed around, and surprisingly enough, they left the area more often when there was noise compared to no noise. But I wouldn't say that there is any difference between before and after. It's definitely not supported significantly in the statistical models.
How many repetitions did you have for this?
Yeah, I have to remember now. So it depends, because I looked also at spring and autumn. So together it's 27 springs and autumns. But in autumn itself, it's like, yeah, about a half of that.
Mm-hmm. Okay. I think Muhammad had an answer or a question. He will have an answer.
Yeah, I see.
So my question is basically related to, as you know, that airplanes also have a very bad effect on the behavioral changes of the birds. So I just wanted to know that whether these behavioral changes are like long-term, or whether they can actually affect their communication with the mates in a very bad or particular way, or this could lead to a disastrous effect on their mating as well. Because as far as I'm concerned, that the birds that are affected by the airplane's noise actually do behave strangely, and they actually start like fighting with each other, as far as I know. And whether these negative effects could be overcome or not.
So it really depends. It's a complex question, and you seem to be very aware of this topic. So I'll tell you that generally speaking, there's quite a lot of research done on airplane noise or airports specifically. And airports have really negative impacts on birds. We know that they can actually even cause to the reduction in the hearing capabilities, deafening of birds, not complete deafening, but we don't have any evidence for complete deafening of birds in nature. But we do have examples for reduced hearing capabilities, aggressiveness that you've just mentioned, birds fighting more often when they're exposed to noise. There are research projects on that. I don't remember specifically on airplanes noise, but definitely we know that birds that are exposed to noise tend to be more physically aggressive in some species, again, not in all species. And it could be possibly somewhat because of that they don't hear each other very well at the vocal communication level. And then they get nearer to each other in order to hear each other. And then drift to physical attack faster than they would have without the noise. And we definitely know that birds' breeding success in those areas is reduced. So yeah, it definitely has negative impacts that are long-lasting effects on the population level. If we considered also the reduced breeding success, reduced hearing of other individuals means that also females can no longer choose among many males, but a limited number of males. So their mate selection is also hampered by airplane noise. And people have shown lots of different impacts on breeding behavior and mating behaviors in ducks. In some cases, it lasts only a few hours. But again, reduced hearing capabilities last for several months in birds before they can regain their cells in the ear and hear again as they used to before. So these effects last from several minutes of acute stress in their body or short-term stress in their body to very long periods.
Thank you. Oh yeah, sure.
Okay, thank you so much.
Hi, first of all, I want to say that your presentation was very informative and you select very simple words and I understand very well. Thank you for that. And for second, I have a question that as I know that there is a threshold limit for human beings for the noise pollution, like in some industries, like when the noise level will be more than 90 decibel or up, their hairs can be disturbed, their hearing ability can be disturbed. So I want to know about the threshold limit for the birds because of course they are more sensitive. So I just want to know about that.
Sure. So definitely, yes, we have our limits and thresholds. And for example, in Israel, the limit for a loud party or a rock concert would be 85 decibels. So it just varies a little bit between countries, but most countries do acknowledge that we have limits, and at night we should have lower levels of noise. For example, here in Israel, it's 45 decibels at night and 55 a day. So we know that really well. We are not exactly sure where is the threshold for birds, and we also have to take into consideration that when we say birds, we talk about 10,000 species. So they definitely do vary in their hearing range, and this also is manifested by their body size, their relevant habitat where they come from, and so we can tell quite well for most species what is their hearing range because we can sometimes measure it directly and most times assume that based on other species. There was just now published a nice paper, I think it was done in China, where they actually managed to measure behaviorally without any physical intervention how birds hear or not hear some sound. I forgot completely now the name of the paper. I'll have to dig that deeper in, but we can say that based on Shannon et al., for example, 2016, the threshold is probably quite similar to humans. About 40 decibels is already perceived as impactful noise. Again, for some of the behaviors, for some of the physical effects, but I think Shannon et al. 2016 covers and provides much more detail if you're interested on where exactly passes this threshold, the difference between humans and birds.
Okay, thank you very much for your answer.
Thank you. I think, Sachin, you had a question earlier. You raised your hand.
Yes, thank you for the presentation, really actually informative. I had a question about similar to the decibel. Apart from decibel, considering the decibel, the permissible levels, what do you think as, say, people who live in a city, major cities can do to reduce noise pollution? Does like sharing a public transport more than using cars would be more useful? Then how do you think, other than the decibel level controlling, we can reduce the noise pollution so that it doesn't affect birds or any other animals as well? apart from the decibel consideration?
Yeah, thank you. So I do not think that it is up to a personal level to control for noise pollution. I mean, definitely don't go outside and blast your area with all those Bluetooth devices nowadays that you can find with these huge speakers. But what we see in this experiment, for example, is that the noise that was broadcasted for 2 days didn't have an effect afterwards in my experiment here. However, in a previous experiment that I've conducted on wind turbine noise, I was actually able to show that some of the species, not all species, but some of the species that responded to the noise and were reduced in their numbers during noise treatment were also reduced afterwards, and that it had long-lasting effects. And for example, when we plan festivals or parties outside in nature, or even picnics nowadays, people put quite some loud music, and that should be reduced, especially where you are nearby ecologically important areas. But in my studies, I do not really focus on the urban area, where there are lots of different types of noise. And we can assume that most of the noise sensitive species are not going to be in those areas from the first place.
Okay, yeah. Thank you. Thank you so much.
And just to add to that, there is also this, we're talking about noise levels all the time.
Yeah.
Because that's what most people do. And that's what most planners and conservationists and governmentals can handle. And most physicians on the let's say more applicable side use. But we're ignoring the fact that noise has different frequencies and different temporal patterns.
Yeah.
And so traffic noise from a minor road has a very different temporal pattern from a major road where there is constant traffic. And in that term, we know almost nothing on how the different temporal variation in sounds is accepted or not by wildlife in general or birds in specific.
Thank you. Thank you for your answer.
There's an interesting question from Songkran in the chat, where she asks, what is the sound that birds love, and can we provide it to them? So the opposite of pollution, I guess.
Yeah, so actually this is where most of the studies on birds vocalization started, when people were trying to trap birds and to lure them. And so people were using, sometimes it's hunters, sometimes it's even in ancient times, like I'm talking about tens and twelves of thousands of years ago, people were using different tools to mimic birds' vocalizations to trap them. And so we have evidence for also sounds that birds like or love, and that's mostly other birds' song. And what we know from those studies is that, and definitely people use it up until today to conduct bird ringing and to track birds. So definitely we use the fact that birds really like or are attracted. We don't know if they like it in that term. I mean, love and like is more human-oriented terms that I'm not sure I would like to use, but they are attracted to the sounds of other birds, either from their own species, and in some cases, people were able to show that they're attracted also to other species. And it is also dependent on their own experience. People have been trying to broadcast music to birds to see if that attracts them. The answer is no. Not classic music, not rock music. People have tried that. And people have also tried to broadcast, for example, in Europe, South African species calls, and they were able to show that birds were not attracted to that. So birds were usually attracted to the vocal communication of birds that they are familiarized with. And people used it. I think there was a study I think it was in Finland or in Sweden, where they broadcasted birds' noise in a nature reserve to make sure that the birds will come into the protected area rather than outside of it. And they managed quite well with endangered species. It wasn't just done with the common birds. That's a lot of effort to just put speakers inside forests in the middle of nowhere. But they've done that with some endangered species. I'm sorry, I don't remember exactly this example, but they've done that, and they were able to raise the number of birds that were actually breeding inside the protected habitat. So it's doable. It's a lot of work, and we don't always know exactly how birds will actually respond to the noise that we're broadcasting. So I have tried it once with like one season here with migratory birds, blackcaps. Forgot the name in Hungarian. Sylvia tricapilla in
barát poszáta.
Oh, that's for sure. Yeah, I forgot that. Yeah, oh, I need to fly again to Hungary and hear all these names again. So yeah, and they were attracted to conserved stopover site during migration, based on these speakers and sounds. But we don't know from how far. We didn't have the tracking system that we have nowadays, so we don't know for how far this impact travels. From how far can we get birds into those protected areas when we broadcast their sounds? We don't know yet.
Okay, and there is this last question. I don't want to keep you too long. This question is about, is it right to assume that all birds in urban areas are tolerant to noise pollution?
Definitely not at all. So what I said is that we have probably less of those sensitive species, but we cannot assume that all species within the urban areas are tolerant. And the word tolerant is very risky as well, because even if birds can handle to some extent some levels of specific noises that they are familiarized with now, we cannot assume that it's all types of noise. We cannot assume it's all intensities of noise. We cannot assume it's throughout the day. I mean, there are owls inside city that can probably last in urban areas because they sleep during the day and are active during the more peaceful, quiet hours at night when they're foraging. We cannot assume that noise at night will not affect them negatively, for example. So we can assume that most of the top sensitive, most noise sensitive species are outside of the urban areas, but definitely not all. And it doesn't mean that all species can tolerate all types of noise. They have to invest in that, either physically or behaviorally, as we have shown now that they make shifts, but these shifts also have their limit. To some extent, birds can move to more visual vigilance rather than vocal vigilance. But then there is a limit to that. If they don't feed at all anymore, they will probably die. And so there is a limit to everything.
And maybe one comment / question from me. It was really enlightening to me that the data of 1,500 meters of a distance that still has an impact on breeding biology or breeding performance. And I was just thinking that most of the research that we do, or researchers who work on birds, usually approach their study site on road, right? So most of the knowledge that we have on breeding performance are probably biased because of the proximity to roads. And I was wondering if there is can we actually assess the difference between this road impact on research and versus if people go and do more inland or distant studies where they assess breeding performance. So I'm just curious how much of a bias there is on breeding performance because of the proximity to roads that we use during our research.
Yeah, so first of all, there must be. And nowadays we don't acknowledge that, and most papers do not specify the distance from roads or other noisy infrastructures. Sometimes it's enough to have just a water pump at the edge of a field, and that would affect the breeding density, and we're not even aware of that existence because we're not even there when the pump is on, and we don't even notice that sometimes. But I also mentioned the traffic volume. And so the number of cars per day is also having quite an impact. And we can assume that most of those study sites, even if we approach them by cars, those are the minor roads. And so we expect there to be a lot less impact of traffic noise on those sites.
Yeah, probably. Okay. So
we're not that bad. We're not doing that bad.
If we use dirt roads somewhere
right
in backcountry fields, then we are probably fine. Then there is the agricultural impacts, and that's a different story for a different day. But it was so great to have you here and sharing your research, exciting results. Thank you so much. We
Thank
really
you for the
enjoyed
invitation.
it. Thanks a lot, and hope to see you in one of these ringing camps one day.
I surely do hope to get back to Hungary as soon as possible. Thank you so much.
All right. Thank you. Have a good day, everybody.
You too. Bye-bye.
Bye-bye.
Thank you.